Okay, in this video we're going to talk about the definition of a derivative and the tangent line problem. So looking at the very first part here, you are asked to find the limit as h approaches 0 of f of x plus h minus f of x all over h. And then you're asked to write the equation of the tangent line to the graph of f of x at a given value of x. All right, so the first thing I would do before I went through a lot of this, I would do a little part at a time. And so in other words, I would do f of x plus h, and I would see what that looks like first. And so that means everywhere I see an x in this function, here and here, I'm going to substitute in x plus h. So I'm going to have 7 minus 3 times x plus h minus x plus h all squared. Now I would continue to simplify this sum because I need to know what that value is so I can plug into this limit problem. And so I'm going to have 7 minus 3x minus 3h minus, and again here, and I'm going to do the brackets because when I pull this out, I'm going to have x squared plus 2xh plus h squared. And I want to make sure I include that negative with each term. So then here, as we continue, we're going to have 7 minus 3x minus 3h minus x squared minus 2xh minus h squared. And it doesn't look like there's a tremendous amount there that I can put together. So there is f of x plus h. That's this portion here again. Now I'm going to change colors, and now I'm going to bring in my function f of x. So I'm going to look at f of x, and f of x is just what I'm given here, 7 minus 3x minus x squared. Now keep in mind this limit, it wants us to find the limit of f of x plus h minus f of x. So I need to subtract these two functions. And so I'm just going to go ahead and let's keep in mind I'm going to take that entire function and subtract it. So let's see what we're going to end up with. We have 7 minus 7, so those are going to cancel. We have negative 3x minus a negative 3x, so those are going to cancel. And I have negative x squared minus a negative x squared, so those are going to cancel. So this top portion, after I subtract those, it looks like I have the limit as h approaches 0 of, and I had negative 3h minus 2xh minus h squared, and that is all going to be over h. Now it looks like I have a GCF in the numerator, so I'm going to factor out that h. So I'm going to have the limit as h approaches 0, and I'm factoring an h out of each part, and we can also factor out a negative if we want, since all the terms are negative. So if I factor out negative h, I have 3 plus 2x plus h, and all of that is over h. So now those h's will cancel, and I'm left with the limit as h approaches 0 of the negative parentheses 3 plus 2x plus h. And so now h is approaching 0, so that means everywhere I see an h, that's going to go out to 0. So it looks like my final answer here, if h goes to 0, then that goes to 0. So my final answer is going to be negative 3 minus 2x. All right, so there's going to be that limit value. Let's move on to the next one. And again, here, keep in mind what we're going to have to do with this, and I think this one might get very disgusting very quickly. So first thing is we're going to have to find f of x plus h, or in this case, g of x plus h. And so that's going to be the square root of 2 minus parentheses x plus h. And that's about all we can do for that. And then we're going to look at g of x, and that's going to be the square root of 2 minus x. So let's look at what happens here. I have the limit as h approaches 0 of, and I have the square root of 2 minus x plus h minus the square root of 2 minus x, and that is all over h. Well, if I sub in a 0 here, I'm going to get 0 over 0, which means I have some algebra that I'm going to have to do. And so what I'm going to do is try to simplify up this function before I do anything else. So I'm going to go through and do some rationalizing, and I'm going to use the numerator to do that. So I have 2 minus x plus h minus the square root of 2 minus x all over h. And now I'm going to use the numerator, and I'm going to rationalize this. So I'm going to have the square root of 2 minus x plus h. But with our rationalizing, we're going to change that minus in between here to a positive. Square root of 2 minus x. And then in the denominator, I have to make sure I multiply by the same amount because I don't want to change the value of this function. I just want to change the ugliness of it. So let's see, what are we going to end up with if I rationalize here? And I'm going to go ahead and bring down this limit as h approaches 0. And I will need to multiply across the top and bottom, but I'm going to be super lazy and use some previous knowledge. I do know with FOIL I have to multiply the first terms, and notice the radicals will cancel each other out, and all that's left is 2 minus x plus h. I also realize that when I do my outer term and then these inner terms, they're going to cancel each other out. And so I'm only left with multiplying way out here those terms. So a positive times a negative is negative. And again, those radicals cancel each other out, so I have 2 minus x left. And again, I'm super duper lazy, so in the denominator, I'm not going to multiply any of this if I can help it. I'm just going to do the square root, and I'm going to do 2, let's see, what are we going to get? 2 minus x plus h. And then that's going to be times, oh, I left out the plus, and square root of 2 minus x. There we go. Now that looks better. I'm looking at the numerator. I need to see if I can get anything at all to cancel. And it looks like if I start distributing that negative, it looks like the 2's would cancel because I'm going to have a 2 minus 2. And then I'm going to have a negative x and a positive x. And then it looks like I'm going to have a negative h in the top. So let's see, I have the limit as h approaches 0. And I'm going to have this negative here is still sitting there. So let's see, what are we going to end up with? Negative, it looks like just negative h. All of that gobbledygook is over, yippee-yi-yay, h times the square root 2 minus x plus h plus, oh my goodness, the square root of 2 minus x. Now let's see, those h's are going to cancel. So our limit value, our limit as h approaches 0 of negative 1 over, and it looks like I'm going to have the square root of 2 minus x plus h plus the square root of 2 minus x. And now if h approaches 0, that means that this h in the denominator is going to go to 0. And so that means I'm going to have negative 1 over, And then I'm going to have the square root of 2 minus x plus, so let's extend this line, the square root of 2 minus x. Well, that's going to be negative 1 over 2, because now I have 2 of those. So 2 square root of 2 minus x. So there's going to be that limit worked out. Awesome, awesome. All right, let's continue on. Okay, now it wants us to find the equation of the line tangent to the graph of f of x at x equals 1. Now, we just worked out our previous f of x up above, but here's something that I want us to compare and see. So when we talk about equation of the tangent line, we have the formula y minus y1 equals m times x minus x1. And we don't ever need to forget that. It's very important that we have that in our minds. Now this x1 and this y1, and let's write that in, x1 and y1, that's going to be a given point. And it's really a given point on f of x. That's important for us to know. That is a point on f of x. Now m, that's another value we need. M is the slope of the tangent line. At x1, y1. Okay, so let's see, we're given 1, x is 1, so we need to find y, so we need to plug back in. So f at 1, well, that's going to be 7 minus 3 minus 1, so that's going to be 4 minus 1, so that's 3. Now, I have my x1 and y1, that's going to be 1 comma 3. Now, if I only knew the slope of that tangent line, well, then I could write my equation. Well, that's going to be what we just found. When we go through that entire process, we are finding the derivative. And we already, strangely enough, we already know what that derivative is. We can find the derivative of this pretty quickly. We see that f prime at x is going to be negative 3 minus 2x, which is what we just got previously. So we just shown the derivative by its definition. Now, it's very quick just to go through with the power rule. And I need to know, well, what is f prime at 1? So I need to substitute that in, and I'm going to get negative 3 minus 2, which is negative 5. So now I'm ready to write my equation of my tangent line. I'm going to say y minus y1, which is going to be our 3, equals our slope times x minus 1. And this is going to be the equation of your tangent line. And we can use that tangent line to do some approximations at points. We can also use that tangent line to tell concavity. So there's quite a bit that we can use there. All right, so we're going to do the same thing for number 4. Number 4, we have here again, we need the equation of the tangent line. And we're given x, so we need to find here g of that negative 7. So g of negative 7 is going to be the square root of 2 minus a negative 7. And so we're going to get 3. Now, if we only knew what g prime was, and we saw earlier what g prime of x is, now let's work it out with this. So we're going to have 2 minus x raised to the 1/2. And now we're going to do our power rule. So we're going to have 1/2 times 2 minus x to the negative 1/2. And then we have to come back and do the derivative of the inside. And the derivative of negative x is negative 1. All right, now we're going to have g prime Now we need to find g prime of negative 7. So we're going to have negative 1/2 times, if I substitute in that negative 7, I'm going to get 9 to the negative 1/2. That's going to be 1 over the square root of 9. So 1 over the square root of 9, that's going to be times negative 1/2. So I'm going to get negative 1/6. Now I'm ready for the equation of the line. So we're going to do y minus y1. Well, that's what we found earlier. That's going to be 3 equals our slope at that point, negative 1/6, times x minus our original x value, which was 7. And this is going to be our equation of the tangent line. All right, notice it wants us to find h prime at x using the limit process. And of course, nobody wants to do that since we know that we can find this limit by using our quotient rule. But let's just for grins see if we can do it. All right, so using our limit, we need to find h at x plus h. So that means in the numerator, I'm going to have x plus h. In the denominator, I'm going to have x plus h minus 3. And then we need our h at x, which was x over x minus 3. Oh me. So keep in mind our limit as h approaches 0. This is our definition. It's going to be x plus h over x plus h minus 3 minus x over x minus 3. And all of that mess is over h. All right, so now we're going to have to find a common denominator of that numerator. Now, I would do all of the cross multiplication magic on that. So let's see what's going to happen. We have the limit as h approaches 0 of, and I'm going to have x plus h times x minus 3. Then that's going to be minus, and then I'm going to multiply the other direction. So x times x plus h minus 3. And that is all over x minus 3 times x plus h minus 3. And then all that stuff is over h. Holy freaking cow. All right, so let's see if we can do all of this algebra. Now, all of this is really, we can shorten this with the quotient rule, but we just want to flip through this just to see. Limit as h approaches 0. And let's start doing some of this algebra. So at the top, I'm going to FOIL out, and it might be useful to change colors. This portion here, I'm going to FOIL all that out. So I'm going to have x squared minus 3x plus xh minus 3h. Okay, and now let's swap colors, and I'm going to look at this portion. So that's going to be minus x squared minus xh plus 3x. And I'm far too lazy at the moment to do anything with this denominator. I would only multiply out the numerator, but it's because I think stuff will cancel. I doubt a lot of stuff's going to cancel in that denominator. Now it might, but I doubt it. And that's all over h. All right, now let's collect our like terms and see what we have now. And again, starting back over at the limit as h approaches 0. So it looks like that we're going to get to cancel, I can get my pen to work, that'd be great. Okay, that's going to cancel here. Those 3 x's are going to cancel. X plus h's are going to cancel. So it looks like I'm left with just a negative 3h. Well, alrighty. So let's see. I'm going to have negative 3h all over this x minus 3 times x plus h minus 3. Now that's this whole fraction here. So I'm going to divide all of that fraction by h. So I really need to multiply by the reciprocal, or 1 over h. And let's see what happens with that. These h's are going to cancel. So that h and that h are going to cancel. And let's go ahead and apply the limit too while we're doing this, so we don't have to write too much more. Oh, I forgot to change to a pen instead of a marker. So negative 3 over. And if I apply my limit, h is approaching 0. So h is going to be gone to 0. Notice I'm going to get x minus 3 times x minus 3, which would be that bottom squared. So we should get the same thing regardless of doing the quotient rule or doing this limit definition. So now I know that h prime, well, dang. So now I know that that h prime at x, I know what that derivative is. H prime at x is negative 3 over x minus 3 all squared. So now I have what I like to call my slope generator. Slope generator. All right. So let's go through and see if we can't use this on some of the other problems. All right, so let's bring the derivative back up here. H prime at x, that was going to be negative 3 over x minus 3 all squared. All right, now let's go ahead and find the slope of the tangent line drawn to the graph of h of x at x equals 4. So all we need to do now is substitute in 4. And so we're going to have negative 3 over 4 minus 3 all squared. So that's going to be negative 3 over 1, or negative 3. All right, so look at 7. Find the slope of the tangent line drawn to the graph of h of x at x equals negative 1. So again, we're going to have h prime at negative 1. Notice my notation is h prime, not h. And we're going to have negative 3 over negative 1 minus 3 all squared. So negative 3 over, and that's going to be negative 4 all squared, which is 16. All right, now let's look. We need to write the equation of the line. So here we have x is negative 1. I do need to find h at negative 1 so that I have my y value that goes with it. So we need to plug back in negative 1. So I'm going to have negative 1 over negative 1 minus 3, which is negative 4. Make sure I use the right function there. I don't remember what it was. Yep. And that's going to reduce down to be 1/4. And we already know what h prime at negative 1 is. That's going to be negative 3 over 16. We just found that. So our equation is going to be y minus our y value that we found equals our slope times x minus our x value. All right, there we go. There's our equations of tangent lines.